So my name is Evan Martinuk. I'm a geologist at the New Afton Mine. And I'm here to present about mine census system and our ore analysis at our mine. We've been collaborating for the last couple of years with MineSense and New Gold, so it's a good project. Such a cautionary note regarding any forward-looking statements, looking at the opportunity the system has. So about our operation, we have two mines, the Rainy River Mine, which is near Fort Frances in northwestern Ontario, and then the New Afton Mine, which is just outside of Kamloops, which is where the project will be taking place. So we're copper gold porphyry with production beginning in roughly 2012. Just a little bit about our mine. Yeah, so we are originally open pit mine, and you can see we have 4 different mining blocks. There's our east and west cave, which is our lift 1. It's about 600 meters below surface, and those are now finished mines. Then we have our B3 mine, which is our currently operating mine, and that's about 700 meters below surface, and C-Zone mine, which is about 1,200 meters below surface, and is what we'll be looking to kind of implement the system in. So yeah, we've collaborated since late 2020. MineSense had a front-end loader on surface for the first adaptation, and then we kind of gradually progressed to underground applications. You can see our front-end loader with a bit of the MineSense XRF scanners on the bucket there. Yeah, looking to take it from the shovel sense surface operation to underground application. So at our mine, it's pretty challenging conditions. We have very large, oversized, sometimes like car-sized oversized. We have to people put into the buckets, and that'll interact with our scanners. And then we have some wet material. Every drop point has a water spray, so it's just spraying water to keep the dust down. And then we have just very mixed material. Sometimes it'll be sticky, different fragmentation size. So all sorts of material coming out of the drop points that are going to interact with the scanner and the bucket. Okay, I think I just exited out here. There, we're back. Okay, so yeah, one of the key challenges is just robustness of design. How do you protect this sort of device on a bucket of a shovel? And so it's been proved on surface applications to work, and so MineSense is working on adapting it for underground application. So we've trialed several different designs looking to protect the system, and previous trials have demonstrated opportunity to improve those. And the latest design is pretty promising, so we've proposed a longer-term trial to refine this design, determine the lifespan, how often are we having repairs and maintenance and requirements, and just kind of demonstrate the use case that we have for this, and prove all the concepts that we've kind of put in our MICA proposal. So at our mine, we currently identify all of our material through assay samples. And our assay samples have a bit of a delay in getting results, and they have sampling biases, so we generally get our operators to take these samples for us when they're mining the draw point. And so they might just collect what's easy and close to them and small, and not necessarily representative of the draw point itself. And the sampling size is pretty small, taking 5 kilograms of material that represents over, say, 500 tons of mined rock. And we have a delay in results, about 3 days between sample collection and processing. So, and if we were to do any sort of sorting, we kind of have a 3-day delay, and you want to have repeatability in that sort of understanding that the material is consistent before you make a change. So delayed ore and waste calls are loss in revenue or potential opportunity to decrease costs. So looking at perceived benefits of this MineSense system, we'd be getting an immediate grade result from our bucket as we scan mine from the draw point. And that provides us a good opportunity to choose what to do with that material. So we're looking at New Gold, we're using some autonomous operations on surface to operate some of the scoops, and may have different software implemented to allow for differentiation of material based on our autonomous and sort of dispatching systems. So opportunity to provide value through reducing our downtime for sample collection and just spending that time mining, reducing the costs of sampling, processing, and reducing the amount of waste that's going to the mill and then being processed, consuming energy, reagents, and all that to get that through the system. And then we also have the opportunity to capture ore that was expected or not unexpected in a waste draw point, or capture waste material that was out of a ore draw point. So it's opportunities to sort that material. And there's some environmental benefits. If we're removing waste from the mill stream, then we will create less tailings, and then we will increase our copper output for the ton CO2 equivalent just by creating a higher grade going into the mill. Then other potential benefits would be mill recovery improvements. If we can, maintain a more steady blend of material going to the mill, that'd be a great opportunity. And then also understanding the material in advance of what's going to the mill to give them a heads up if we're seeing more pyrite or other elements of interest. And other environmental benefits might be like the identification of pyrite through this XRF scanner and what we might want to do with our waste rock as mitigation measures. So the goal of the trial is to collaborate with MineSense and determine the proposed benefits or the perceived benefits if they're realized, demonstrate the design robustness in the underground environment and continue working out any sort of improvements on the back end or electronically, and demonstrate that this solution would be working for our C-Zone block cave mine and that we could actually use it and implement it. And it's pretty exciting stuff because this would open up the door for MineSense to underground applications and be a great opportunity for them and then also for us, of course, to improve how we're mining our material. And pretty short and sweet presentation, but if you guys have any other questions. Also, I guess MineSense has a QR code here that kind of shows a brief video about their operations on surface and what it kind of looks like to scan material and differentiate that. So feel free to take a photo of that. But, yeah, that's all I have. Any questions for you guys? Yeah.
What kind of call factor do you get between the MineSense grade and the mill grade?
We haven't, since our current operation, we only have one MineSense scoop operating. We have 4 other scoops doing work. It's hard to say exactly what that factor is, but I think our grades from assay samples and blending and mixing are pretty close to the MineSense system. And because of those sampling biases and challenges, it's hard to say, our samples, not representative as the MineSense bucket, So overall, if we have more data, we'll continue to understand that. Awesome. Thank you.